Hello everyone. Today we're going to be going over section 2.5, which is going to be about formulas and additional applications of geometry. So we have four objectives, our first objective being that we want to solve a formula for one variable given the values of other variables. 2, use a formula to solve an applied problem. 3, solve problems involving vertical angles and straight angles. And 4, solve a formula for a specified variable. So to define a formula is an equation in which variables are used to describe a specific relationship. So some examples would be P is equal to 4S, E is equal to MC squared, and F is equal to 9/5 C plus 32. And the relationships of each one of these formulas is our first equation here, P equals 4S. We have the perimeter of a square. A square has 4 sides, so we can say that the perimeter is equal to 4 times the length of one of those sides. Then we have E is equal to mc squared. We have energy is equal to mass times the speed of light squared. So we're describing energy in terms of other variables, and we're describing their relationship. And then lastly, we have Fahrenheit is equal to 9/5 times Celsius plus 32. So our formula here gives us that formula in figuring out the relationship between Fahrenheit and Celsius. So these formulas are just going to be equations describing relationships. So many of the formulas we need or will use are given in the back of your book. So if you ever need to find a specific formula, you can always go to the back of the book in order to find whatever formula you need. On to objective 1. We want to solve a formula for one variable given the values of the other variables. So the area of a plane, or the two-dimensional geometric figure, is a measurement of the surface covered by the figure. So when we talk about area, it is almost like we have some sort of figure and we're covering the area. We're covering all of those surfaces of that figure, and that's going to give us our area. So our area equations are given for different types of shapes. So in example 1, we want to find the value of the remaining variable in the formula. And in this case, we have a rectangle. So we're saying that our area is equal to the length times the width of our rectangle. And we're going to describe this as just A is equal to L times W. A is a fancy A. So you can write a regular A if you would like. But we have A is equal to 70 and our length is equal to 10. These numbers can sometimes follow along with units if you have applied problems, but we don't really have an applied problem in this case, so we're not going to give them units. So we have our formula for our area. We know that the formula for area is area, so A is equal to length times width. And we have the values for the area and length. So all we need to do is plug these values in. And we're trying to find the value of our remaining variable in this formula. So what we don't have is the width. So we want to find the width. And knowing that our area equals length times width, we can plug these values in. So instead of A is equal to L times W, we're going to have 70 is equal to 10 times W. Then we just want to solve for W. And so in order to do that, to isolate a variable, like how we've done in our last few sections, we can use our multiplication property of equality and divide each side by 10. So we're going to say that we're going to divide these sides by 10. And when we do, 70 can be separated out into 7 times 10, where we're dividing by 10. And we see here we have a 10 in our numerator and our denominator. So we get that W is equal to 7. And all we needed to find was W. We wanted to find the value of the remaining variable in our formula. So instead of a question mark, we have W is equal to 7. So that'd be the missing value there in the area of our rectangle. Objective 2, we want to use a formula to solve an applied problem now. So the perimeter, which we touched on in the very beginning, of a plane or a two-dimensional plane, we have a geometric figure is the measure of the outer boundary of the figure. So instead of thinking of covering whatever shape that you're thinking of, you're now only considering the outside lengths. So for rectangles, squares, or triangles, we would calculate this by taking the sum of the lengths of the sides. So we're just adding those lengths of sides together. So for example 2, a sandwich has the shape of a triangle. Well, technically half of the sandwich. But we're going to say the sandwich has the shape of a triangle. The longest side is 3 centimeters longer than the shortest side, and the medium side is 1 centimeter longer than the shortest side. If the perimeter of the triangle is 16 centimeters, what are the lengths of the sides? So we have a picture drawn here. A lot of the times when you get these questions, you will probably not have a picture. You may or you may not, but it is always extremely helpful to try and draw out a picture as well as you can. And remember, for this question that we're dealing with, we are only considering the sides. So we're considering these sides here. So if we're considering these sides and we have an applied problem, we want to use our steps to calculate our perimeter. Our normal steps that we use with applied problems. So remember, step 1, we have to read. So with step, oh, that's way too big. So with step 1, we've read our problem. We know that we want to find the perimeter. Step 2, we want to assign our variables. So in this case, we're taking our longest side and we're comparing it to our shortest side. And we're also taking our medium side and comparing it to our shortest side. So we're going to let X be our shortest side. So we're going to say X is the shortest side. Then we determined that our medium side was 1 centimeter longer. So we have X plus 1 is going to be our medium side. And our longest side is 3 centimeters longer. So we'll have X plus 3 is our longest side. Sorry, S. I realize that they are labeled as S. So S is the shortest side, S plus 1 is the medium side, and S plus 3 is the longest side. So we see here our picture, each one of our sides are labeled. So we know which one is our shortest, medium, and longest side. And this was step 2. So for step 3, we want to write out our equation. We know that the perimeter of a figure is the measurement of the outer boundary, or calculated by taking the sum of the lengths of the sides. So what we're doing is we're adding each one of the sides together and we're letting it equal the perimeter. So in our equation, we're going to have the shortest side plus the medium side plus the long side, and this is equal to our perimeter. Now we have equations for our short side, medium side, and long side, and we know what the perimeter is. It's 16 centimeters. So we're going to factor these in. Our short side, we said, was X. Our medium side was X plus 1. And our long side was X plus 3. and our perimeter was 16 centimeters. We're going to leave the units off. We can say here unit equals centimeters. We just have to remember to put it back in at the end. So we have our equation. Our equation is going to be x plus 1 plus x plus 3 is equal to 16. Now step 4, we want to solve. So step 4, we solve our equation, which is x plus 1 plus x plus 3 is equal to 16. And we want to combine our like terms. So we have 3 x's, we combine those terms, we get 3x. And then we have a plus 1 plus 3, so 1 plus 3 is 4. So simplifying this, so here we combined like terms. To get 3x plus 4 is equal to 16. Now we can use our addition property of equality and subtract 4 from both sides to isolate our x term. So we get 3x plus 4 minus 4 is equal to 16 minus 4. And this is our addition property of equality. Simplifying this, we get 3x is equal to 12. 16 minus 4 is 12. And then we want to divide each side by 3 to isolate x. And this was using our multiplication property of equality. And when we divide 3 by 3, we get 1x, and 12 divided by 3 is 4. So we're saying that x is equal to 4. For step 5, we want to state our solutions. So since we got that x was equal to 4, we say that our shortest side is equal to 4 centimeters. Then our medium side was x plus 1, so 5 centimeters. And our longest side was x plus 3, so 4 plus 3 is 7 centimeters. So we have our answers here. And finally, step 6, we just want to check. So step 6, if we're just checking, we know that we're adding up all of our sides. So remember we had x plus 1 plus x plus 3, and we're saying this is equal to 16 centimeters. X is going to be 4. So we have 4 plus 1 plus 4 plus 3, which we know is 4 plus 5 plus 7, not 17. And so we add these values, 4 and 5 is going to be equal to 9, and 9 plus 7 is 16. So our solutions are correct. Just enough room. So that would be how we would find the perimeter of a shape, specifically a triangle in this case.